48 light-years from Earth, a rocky planet is leaking helium into space. Astronomers caught the gas streaming off it during a single night in September 2024. And the leak itself is the discovery. It is the first spectroscopic evidence of an atmosphere on a rocky planet in the habitable zone of another star. A planet cannot leak an atmosphere it does not have.
Here is why that logic matters. Rocky planets around small red stars were supposed to be bare rock. A red dwarf's habitable zone sits close to the star, and the star soaks that zone in X-rays and extreme ultraviolet light, radiation that heats the top of an atmosphere until it boils away. Stack up billions of years of that, and theory said worlds like this one should have been stripped naked long ago. Astronomers have hunted for air on rocky planet after rocky planet, and mostly come back with flat, empty readings. So when the evidence finally arrived, it did not look like a calm blue sky. It looked like erosion, caught in the act.
The planet is called LHS 1140b, and astronomers have watched it closely since its discovery in 2017. It weighs about 5.5 times as much as Earth, and is about 1.7 times wider, a super-Earth, dense enough to be mostly rock. It circles its star every 24.7 days, and at that distance, it receives roughly 40% of the sunlight Earth gets. That is enough, in principle, for liquid water, which is all the phrase habitable zone actually means. And its star is one of the friendliest red dwarfs a planet could ask for. Old, quiet, and calm for more than 3 billion years.
The detection comes from a team led by Colin Cherubim at Harvard and the Center for Astrophysics, published in the journal Science in July 2026. And there is a twist that makes the story better. Cherubim predicted this. During his PhD, he built models of how atmospheres on small planets evolve, and the models kept insisting on something strange. A world like LHS 1140b should end up wrapped in helium, and that helium should be leaking. His own advisor was skeptical at first. Nothing in our solar system looks remotely like that. There was only one way to settle it. Point one of the largest telescopes on Earth at the planet and watch.
That telescope is the 6.5-meter Magellan clay on a dry mountaintop at Las Campanas Observatory in Chile, fitted with a spectrograph called Winard that slices near-infrared starlight into extremely fine shades of wavelength. Nobody can photograph this planet's atmosphere directly. At 48 light-years, the planet is an invisible speck lost in its star's glare. So the team did something smarter. They used the star itself as a backlight. Every 24.7 days, LHS 1140b crosses the face of its star and blocks a small fraction of its light. If the planet were bare rock, that would be the whole story. The star dims a little, then recovers. But if the planet has an atmosphere, a thin ring of gas around its edge also filters the starlight passing through. Atoms in that gas swallow very specific wavelengths. So at exactly those colors, the planet casts a slightly bigger shadow. It takes a deeper bite out of the star. Read the starlight finely enough, and the missing wavelengths tell you what the gas is.
Helium is the perfect gas to hunt for 3 reasons. First, the star's own hard radiation kicks helium atoms into a strange, long-lived, excited state. Astronomers call it metastable. And atoms parked in that state absorb one very specific shade of infrared light at 1083 nanometers. That shade happens to pass cleanly through Earth's own sky, so a ground-based telescope can see it. Second, helium is chemically inert. Nothing reacts with it, nothing binds it, so its signal stays clean. Third, that metastable state really only gets populated in the thin, hot outer edge of an atmosphere, exactly the layer a planet loses first. For years, this trick has caught gas boiling off giant planets. No one had ever seen it from a small, rocky world in a habitable zone. On the night of September 23rd, 2024, the geometry lined up almost perfectly. Both planets of the LHS 1140 system crossed the star that night, 39 minutes apart, and for 6.5 hours, the team recorded spectrum after spectrum. When the outer planet slid onto the star, a dip appeared at exactly the helium wavelength, 1.25% of extra dimming, far more than its rocky body alone could cause. The cloud of absorbing helium was half again as wide as the planet itself, and the absorption began before the planet's solid edge even touched the star, helium streaming out ahead of it along its orbit, the way a comet grows a tail.
Now comes the part that turns a leak into proof. ESCAPE sorts atoms by weight. Heat the top of an atmosphere, and hydrogen, the lightest atom, boils off easiest. Helium, 4 times heavier, follows more slowly. And everything heavier still, carbon, nitrogen, oxygen, water, resists being dragged along at all. The team's models put this planet's outflow at a few hundred tons of gas every second. That sounds violent, but at that strength, the wind can only lift atoms up to about 9 times hydrogen's weight. Lifting oxygen out of this atmosphere would take roughly 10 times more escaping power than the planet actually has. So run the clock forward for billions of years. Hydrogen streams away first, which means the upper atmosphere grows steadily richer in helium. And that is exactly what the spectrum shows. The signal can only be reproduced by a wind that is almost pure helium, about 1 hydrogen atom left for every 1,000 atoms of helium. That composition is the fingerprint. It is what an ancient, slowly eroding atmosphere looks like from the outside. The lightest gases bleeding away for eons, while the heavier ones stay locked below. The leak is not the atmosphere dying in front of us. It is the visible edge of an atmosphere that has endured.
The system even ran its own control experiment. The innoplanet, LHS 1140c, crossed the star that same September night. It is a smaller world, under 2 Earth masses, orbiting so close that its year lasts less than 4 days, and it takes about 5 times the radiation Earth gets. By the logic of ESCAPE, a small, heavily blasted planet like that should have been stripped bare long ago. And the data agree. From planet C, no helium at all. 1 star, 2 rocky planets, and the physics called both outcomes correctly.
Then the story sharpened. In September 2025, the team came back to the same planet with the same instrument, and the helium was gone. Nothing at that wavelength, down to about half the strength of the original signal. That sounds like trouble, and it is honest to say the detection has so far happened once. But it is also exactly how ESCAPE should behave. The wind is powered by the star's high energy output, and that output flickers over months and years. In a quieter stellar state, or with the outflow running slightly hotter, the helium signature slips below what Windored could see in that 2025 transit. What they caught in 2024 was 1 moment of a variable process. Only more transits will reveal its rhythm.
So here is what this discovery is and what it is not. It is spectroscopic evidence that a rocky planet in another star's habitable zone still holds an atmosphere. It is not breathable air. Helium traces only the top of the atmosphere, and nobody has yet measured what sits underneath. It is not a sign of life. Helium says nothing about biology. And liquid water remains unproven. Earlier observations hint this planet could even be a water-rich world, but hints are all they are. What the leak does prove is that heavier gases had every chance to stay. Whether they actually did is the next measurement.
That next measurement is already on the calendar. LHS 1140b has been selected for the Rocky Worlds program, a dedicated campaign on the James Webb and Hubble Space Telescopes built to answer one question:
Do rocky planets around red dwarfs hold on to their air? One of the paper's authors expects a verdict for this planet within 4 to 5 years. Either molecular fingerprints from the lower atmosphere, gases like carbon dioxide and water vapor, or a firm case that there is nothing more to find. Either way, something changed this year. For decades, the survival of air on rocky worlds around red stars was a theory problem. Now there was a planet, 48 light years away, where we have watched the air escaping, and the escape itself was the proof that it is there.